All right, so we are going to be starting today. This is unit 5.3.2, probability, multiplication, and exclusivity. Now, the second half here, the exclusivity part, you won't have to worry too much about it. I'm just going to be showing you guys what it is. It won't be on your test or anything, so don't worry. Sorry, your quiz or anything, so don't worry about that. All right? Now, so, come on in. Can you get the door? Thank you. All right, so the multiplication rule, as it states. Come on, oh, please. Okay. So, the multiplication rule is used to find the probability of two occurring in sequence. When I say in sequence, I mean back to back to back. Most of multiplication probability is going to be dependent events. Very rarely do we actually have an independent probability and it's multiply the two together. Okay? Okay, so, for example, the equation would be the probability of A and B equals the probability of A times the probability of A onto B. Okay? And what that basically means is that once you have the probability of A, you need to manipulate the next probability. Again, that's for dependent events. However, if by some fluke chance you do have two probabilities that are independent and you multiply them together, the equation can be simplified to the probability of A and B equals the probability of A times the probability of B. Okay? So, again, that's why we covered independent versus dependent first. I wanted to, again, get the wording out there so that way when I threw this at you, you weren't like, wait, what in the world? How do I tell the difference? Let's go ahead and take a look at an example. All right? Speaking of cards, two cards are selected without replacing the first card from a standard deck. Find the probability of selecting a king and then selecting a queen. So, we're looking at the probability of selecting a king and a queen. That means that the probability of K is first, but the probability of the queen is going to affect the probability of a king. Okay? In this case. So that means that the probability of getting a king is 4 out of 52. 52 cards in deck. There's four kings, one for each suit. Multiplied by, there are 4 queens. We haven't taken a queen yet. So 4 times 51, because we've already lost one of the cards. That gives me 16 over 2,652, which is roughly 0.006. For some context, if you're playing blackjack, that means you have a less than 1% chance to pull 2 face cards.
I hate playing blackjack.
I love 21. Okay, but the point is that as you are basically playing the game, you can actually calculate your odds, okay? Some hands are really strong once you get them, and then what happens is the flips. You basically find the what was the previous? We talked about it. Hang on, I gotta find the term. We find the complement. We find the complement. Basically, then determine, okay, what is the probability of my hand winning? I have basically over at least a 99.4% chance of winning this hand, unless the dealer gets 21 or perfect 21. Those are some good odds in your favor. That's a hand you want to bet heavy on, because the dealer unlikely will not beat it. Okay?
Yeah.
All right, does that make sense? All right, now, and real quick, before we jump into exclusivity, there's one other example I talk about in the back of this book. I can't, I'm going to find the blank spot. There we go. All right, I'm just going to use the blank page on here, but there's also something called compound probability. The difference between them is honestly negligible. Compound just means that instead of doing once and twice, we're going to keep going, okay? We can go 3, 5, 7, 20 times until we run out of stuff to pick out of the bag, okay? So, let's talk about a hypothetical. Let's say I have a bag containing 4 red marbles, 8 blue marbles, and 2 green marbles. Okay? If 2 marbles are drawn out of the bag, what is the exact probability that both marbles will be drawn red? Okay. So, the probability of drawing 2 red, that's basically what we're talking about. Their total marble count is 4 plus 8 plus 2, which gives me 14. The number of red marbles, or num dot for short, is 4. So red, the probability of red on first draw is 4 out of 14. Then the probability of red on second draw is 3 out of 13. Okay? It's a compound event. Compound event, which means we got 4 over 14 times 3 over 13, which gives me 12 over 182, which reduces down to 6 over 91. And that is the exact probability. If I had asked for, let's say, the decimal, you would then just convert it round to 3 decimal places or however many I would state. If I asked for the percentage at the percent of probability at the 10th place, then you would basically find it what would be the 10th place. So if I did that, I'd have 6 divided by 91. Oops. I get 0.0659. Multiply that by 100. So I have a 6.6% chance of choosing 2 red marbles out of 14. Okay? Now, again, these compound events can keep going. They don't necessarily be 2. I could basically add a secondary step on this and say, what's the chance of me choosing green on my third try? Okay? After taking out 2 red marbles. So that means that we would have the probability of, I'm going to do red 1 for the first times the probability of red 2 for the second times the probability of green 1, meaning that on, green 3, third try. Okay? Should be a 3, not a 1. That means that we're going to have 4 over 14 times 3 over 13 times, now, the total amount of marbles has now gone down to 12, but the number of green marbles is still fresh, which means I have 2 options. Okay? If I multiply all that across, 4 times 3 is 12, 12 times 2 is 24, 14 times 13 times 12 is 2,184. Equals, so 24 divided by 2,184 is 0.0109. I'm going to do a squiggly here and round it to there, which actually is going to round to 0.0110, which, if we just multiply that by 100, we should get roughly 1.1%. So I just cut my odds down a ton from 6.6 to 1.1 because now I'm trying to get a green. Okay? You can see how this really can get interesting in terms of playing certain games and how you can rig the system. Okay? All right, so real quick, we're going to now talk about, oops, I lost my place. Where am I? Nope, that's not it. Where is exclusivity? Oh, I know. There we go. Now it's right. It's rain. Okay, now mutual exclusivity. Okay, real quick, I just want to talk about this. We're not going to throw problems at you, like I said, you guys, but really quickly, exclusivity essentially is when 2 events, A and B, are mutually exclusive if A and B cannot occur at the same time. That means that in order for you to essentially have, let's say, roll a 2 and a 6, you have to have 2 sets of die. You have to have 2 dice, not just 1. You can't roll it and get both answers at the same time. Case in point, event A, roll a 6 on a die. Event B, roll a 2 on a die. These outcomes cannot concur at the same time. Okay? So the events are mutually exclusive. Okay? Now, these two events, the two events are, okay, so let's take a look at some examples. Sorry, I meant to say that first. Randomly select a male student, randomly select a business major. These are not mutually exclusive because I can select a male who is both, well, a male and a business major, okay? Because the students can be both. Okay? The next one, randomly selecting a 2 from a standard deck of cards, randomly selecting a 5 from a standard deck of cards. This is mutually exclusive. You cannot pick both a 2 and a 5 at the same time. Okay? Event A, randomly selecting a queen from a standard deck of cards. Or event B, randomly selecting a heart from a standard deck of cards. Okay? That is not mutually exclusive because both a queen can be a heart, right? Queen of hearts. Okay? Or can be in the suit of hearts. Hopefully I spelled suit right. If I did not, I apologize. But you know what I mean. All right? And that's it. That's mutual exclusivity. Okay? So while I finish writing that up, make sure that you review and make sure you do your homework and practice.